expressions were yesterday. Today we're going to add and subtract them, which is going to require some common denominators. So when you are finding a common denominator, the common denominator of two fractions is the least common multiple of your two denominators. So let's talk about your least common multiple. To find a least common multiple, you're going to be looking at your factors of your expressions. So the first thing I want to do is go ahead and factor these two. So I'm going to factor out my common factor of 2 first. And then I can factor x squared plus 6x plus 9 into x plus 3 times x plus 3. For 6x squared minus 54, I'm going to factor out my 6, and then that's going to leave me with x squared minus 9, which you can factor into x minus 3 and x plus 3. I'm also going to go ahead and factor my 6 into 2 times 3. So now your least common multiple is every factor that shows up in either one. So I've got a 2, so 2 has to be part of my least common multiple. I've got a 3, because there's a 3 in one of them, so my least common multiple has to contain 3. There's a factor of x minus 3, so it's got to be part of my least common multiple. And now each of them have factors of x plus 3. So if you have factors of the same thing, you need the higher amount that occurs in either one. So my least common multiple has to have 2 factors of x plus 3. Not 3 of them, just the higher amount. So there was 1, there was 2. My least common multiple needs to contain 2 of them. All right, so if you're adding or subtracting your rational expressions, you're going to need your common denominator, which happens to be the least common multiple of your two denominators. A lot of times you can just look and think about what you would need to multiply by to get your denominators to match. So like on this one, if I take 2 times 9, that'd get me 18, times a squared would get me a to the third, and times b would get me b squared. So then I can go ahead and multiply and rewrite it with a common denominator. Now if I'm subtracting those, I'm going to write it as a single fraction now, since your denominators are the same. And then you can't really simplify because you can't combine the top. There aren't like terms, and there's no common factors to factor out. If you look at this bottom one, like we talked about yesterday, your denominators aren't the same, but if I multiply by -1 or think about factoring out a -1, then my denominators would be the same. So I'm actually just going to multiply by -1 over -1, which is going to flip that to a -1 and a positive x in my denominator. Then I'm going to rewrite it. Since I have minus -2x, I'm going to go ahead and make that addition. And then I'll write it as a single fraction. On this one, you're going to need to factor your denominator first so you can see what factors you need to multiply for your least common multiple in your common denominator. So if I factor out a 2, then I can factor into x plus 3 times x plus 2. My least common multiple needs to contain all of my factors from either denominator. So if you think about what's going to have to be in your common denominator, you're going to have, if you think about your 4, it's 2 times 2. So you're going to have a factor of 4, or 2 factors of 2. And then you're going to have all of those individual factors of x plus 1, x plus 2, and x plus 3. It's going to have to multiply both of my fractions times whatever it takes to get that as my denominator. So if I look at my second fraction, it already has the factor of 4 and x plus 1. It needs factors of x plus 2 and x plus 3. So I'm going to multiply by x plus 2, x plus 3 over x plus 2 times x plus 3. And then on my first fraction, it has a factor of 2, but it needs another one, and it also needs a factor of x plus 1. So to get 4, I'm going to have to multiply by 2 over 2 and times my x plus 1 over x plus 1. So that'll get my denominators to match. I'm not actually going to start distributing and multiplying things together yet. I'm just going to rewrite it. So my first fraction, numerator multiplied, is going to look like that. My denominator is going to be 2 times 2 is 4, and then all of those factors like I wanted. And then my second fraction has 1 times x plus 2 times x plus 3 on top. And then the denominator is the same, so let me copy and paste here. Oop, cooperate notability. Yeah, sort of, kind of. There we go. Okay. Now, before I do that addition of my two fractions, order of operations, I need to go ahead and multiply the things together in each individual fraction on top first. I don't need to worry about the denominators, they can stay factored. But on top, to add those together and combine like terms, I actually need to multiply things out. So if I multiply each of my numerators together, then I can see when I add those fractions together that there are some like terms. So I can add my 14x and my 5x and get 19x. And my 14 plus 6 will get me 20. So my final expression is gonna look like that. And it's a good idea to check and see if the top factors to see if anything divides out with the bottom, but it does not. Now we're going to look at these things called complex fractions. Don't they sound fun? So they're basically fractions within other fractions, which we don't want to leave them that way. So they're really not too terrible. What you want to do to tackle one is work on the top and bottom separately. So I am going to work on the top of this one and simplify it just like I would normally, pretend the bottom's not even there. So to subtract those two fractions on top, I need to go ahead and get a common denominator, which means I'm going to have to multiply my denominators, or my fractions, times each other's denominators. So times y over y, and y plus 3 over y plus 3. And then I'll have just y over y times y plus 3, and y plus 3 over y times y plus 3. Keep your parentheses so that when you subtract, you remember to distribute your negative. So like I said, I'm going to switch that, flip both my signs on top there, that's important. And then y minus y is 0, and you just have negative 3 on top. So that's the top of your original fraction. Don't forget that it is all over 1 over y, the bottom of your original fraction. Well, how do you divide fractions? You multiply by the reciprocal. So I'm going to take my fraction that I got on top times the reciprocal of my denominator, which is y over 1. You could multiply straight across and get negative 3y over y times y plus 3. Then you can divide out your common factors of y and just have negative 3 over y plus 3. You could also look and divide out those common factors earlier, which is handy in some cases to save you a little bit of work.